All right, welcome to the last radical edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 7, Radical Equations. And since there is no video for Section 7, this is the last one of the chapter, so I know you're happy about that. We're going to learn how to solve radical equations. There's three different types we have to look at. The first type is when the variable is under the square root or cube root. So the first step here is you need to isolate that root. Get the square root, cube root alone on one side of the equation. And then after you have the root alone, then in order to get rid of it, we're going to raise both sides of the equation to whatever that root is to the appropriate power. If it's a cube root, we will cube both sides. If it's the fourth root, we'll take both sides to the fourth power, and so on. And then this step 3 is very important to check for extraneous solutions. Another way to say this is you have to look for garbage answers. Sometimes you do all the algebra correctly, and just by the nature of where these roots exist and where they don't exist, sometimes our answers are garbage and they don't work in the equation. So let's look at this first example. We need to isolate this square root that has the x plus 4 underneath it. So the first thing we're going to do is add a 2 to both sides. So I'd get 10 plus 2 over here, I'd get 12. And now we have to get rid of this times 3 that's in front of the radical. So we're going to divide both sides by 3. And we'd end up with square root x plus 4 equals 12 divided by 3 is 4. So now we're done with step 1. We have the root isolated. Next thing to do is to square both sides. And so if you square a square root, those two operations undo each other. Squaring and square rooting, you just end up with what is left under the radical, and that's what we wanted. So I get x plus 4 is 16, subtract a 4 from both sides, and x is 12. So now let's plug it in and check that answer. So putting the 12 in where the x is, 12 plus 4 is 16, square root 16 is 4, 4 times 3 is 12, and 12 take away 2 is indeed 10. So this answer checks out. This next example is a fourth root problem. Just wanted to do one to remind you that sometimes roots can be written as a fractional exponent. So another way to write this is the fourth root of x. And we want to isolate it, so we want to subtract a 5 from both sides. So if I do that, I get a minus 2. So now the root is isolated. We need to raise both sides to the fourth power to get rid of that fourth root. So I get x equals negative 2 would be 16. And once again, we need to check our answer, so let's plug in the 16 where the x is. Okay, the fourth root of 16 is 2, because 2 times itself, 4 times, is 16. So I have 2 plus 5, and we have a problem. This is not true. All the algebra was correct, but the 16 does not work. That needs to be thrown out. We have no solution here. And we might have noticed that we had an issue here when we were asked to find the fourth root of x, which is an even root, to be a negative 2. So no solution for that one. The next type of equation we're going to look at is when the x, the unknown, is tucked up in the exponent. This is going to lead us into our work with logarithms, but for right now, our skills are limited to, we can only solve these if this step number 1 is possible, if we can write both sides with the same base. So same bases is the key here, and if the bases are the same, the exponents are equal. And I'll be repeating that a few times to see if that can sink in. So the clue here, we look at the small base, base 4. All right, I cannot write 32 as a base 4. 4 squared is 16 and so on. So we need to look for something else. And hopefully you realize that both of these can be written as a base 2 number. So I'm going to remove the 4, and I'm going to put in 2 squared. And 32 is 2 to the 5th. So now I can, forgot my x there, so now I can take this power to a power, go ahead and multiply your exponents. And now we have successfully written these both sides with the same base. Base 2 here, base 2 here. So I'll say it again. If the bases are the same, the exponents are equal. So what we can do is grab these two exponents, remove them, pull them out, and just make an equation with just the exponents. So I'm going to let you look at that for a minute. The bases are the same, the exponents are equal. I pulled them out and made a separate brand new equation, which we can solve, divide both sides by 2. So x is 2/5. So what this is saying then, if to check it, if we have the number 4 and we're taking it to the 5th power, and then you take the square root of that, punch that out on your calculator, you do indeed get 32. Okay, so carrying that same logic here, we want to write these with the same base. And with 25 and 125, pretty easy to see that the base is going to be 5. Remove the 25 and put in 5 squared, and of course we multiply it by our x. And 125 is 5 to the 3rd power. So now this isn't quite what we want, because this base 5 is tucked down in the denominator. We want it to be a base like this. So ask yourself a question. What could I do to flip this denominator up to the numerator? And if you'll recall, when you learned the properties of exponents, you learned that if you have a negative exponent, you flip it and it becomes positive. Well, the vice versa of that is true. If you have an exponent that is positive and you flip it, the exponent becomes negative. Once again, the bases are the same, therefore the exponents are equal. So pull these two exponents out there, write an equation, and solve for x. This time it's 3/2. So if we were to check this, what this is saying then is if you have, it's 25 to the negative 3/2 power is like taking the square root of 25 to the negative 3 power. And if you flip that down, with a negative exponent and do that, you will indeed get 1 over 125. The last type of radical equation we're going to look at is one where the x is not under the radical. But we might have lots of x's in it like we have in this, and we got to get them all together and solve for the single x. So the steps are kind of short, but there's a little more to it. Step 1 says simplify each term. Okay, we can do that. And then do whatever you need with the algebra to solve for the variable. All right, so looking at this to simplify each term, I'm seeing that 16 times 2 is 32, so I can take that 16 out. And one step I could do right away here is subtract an 8 from both sides. So let's do a couple things to simplify it in the first step. So we'd have 7x, square root 16 is 4, so let's bring that 4 out in front, and we leave the 2 behind, and then that would equal x minus 14. And I still want to get all my x's on one side of the equation, so let's subtract an x from both sides. And then we'd have 6x plus 4x square root 2 equals negative 14. So now this is where we have to remember an algebra skill. If both of these terms have an x in them and I want to solve for x, I need to kind of GCF it out or factor it out, pull it out in front, because that's how I'm going to isolate it. So this is an algebra skill. You're going to have this ready to go, and we're going to use this a lot, especially when we get into trig identities. So when you're solving for a variable and it's in both of the terms, please remember to factor it out, pull it out in front. So now to get this x alone, I need to divide both sides by this binomial. So we get x is negative 14 over 6 plus 4 square root 2. So what I did is just divided both sides by 6 plus 4 square root 2. And now we have some simplifying. We have some work to do in this fraction. I'm noticing that each term has a 2 in it, so we can reduce it. Why don't we do that first before we take care of rationalizing this denominator? So let's take a 2 out of all of these terms, just to bring the numbers down a little bit. And now this is a conjugate problem to rationalize the denominator. So I'm going to multiply top and bottom by 3 minus 2 square root 2. So if it helps you to see the distribution, put that in parentheses. Multiplying that by -7, I would get -21 plus 14 square root 2 all over. And then if you FOIL this out, you'd get 9. And then we'd have our two middle terms that subtract away. We'd have our plus 6 square root 2 minus 6 square root 2. So I'm not going to bother writing in those two middle terms. And then we'd have minus 2 times 2 is 4. Square root 2 times square root 2 is 2. Well, this is interesting. So I end up with 9 minus 8, which is just 1. So my denominator is 1. The final answer then is -21 plus 14 square root 2. All right, now you have the knowledge you need to finish Chapter 7, so have a radical time with that.